Hello everyone. So in this lesson, we are going to learn about angular momentum. So suppose you have an object that is spinning and that object has a mass. So for example, this object is spinning in this direction. So if it has a mass and it is spinning, it should have a moment of inertia. And since it is spinning too, it should have a angular velocity omega. So associated to that object's motion, we have the angular momentum. So the angular momentum is just simply the product of the object's rotational mass times its angular velocity. So this is very similar to linear momentum, but in this case we have rotational mass. So recall that in linear momentum you need only to have an object at a moving at a linear velocity, and then its linear momentum is defined as pmv. So angular momentum is just a rotational version of this linear momentum. Okay, now so we have defined previously that net force acting on an object is also equal to the time derivative of momentum. So this is the translational case or the linear case. Now for rotational version of this equation, we have the sum of net torques must be equal to the time derivative of our angular momentum. So in other words, to change the angular momentum of an object, we should have a net torque. So now what if our net torque acting on an object is 0? So what happens to our angular momentum? So if that is the case, 0 equals time derivative of L. So when we have a derivative of a function to be 0, that means that function is constant with respect to that derivative, with respect to time. So meaning angular momentum conserved if the sum of net torques acting on it is 0. So we have our conservation of angular momentum. Pasensya na talaga sa mga doggies namin. Di pa ata napapakain. Anyway, so we have conservation of angular momentum. So the initial angular momentum must be equal to the final angular momentum.